Good morning and welcome back. We're on to lesson 3 notes, which is a review of exponent rules. So this is all stuff you should have seen before, but might need a little refresher on. And this will become in handy when we start working with exponential equations. You'll need to be pretty familiar with your exponent rules. So as a little refresher, a power is a simpler way to express repeated multiplication. So when we have something like 8 to the 5th, this is the same as saying 8 times 8 times 8 times 8 times 8. Okay? The number 5 is called your exponent, and the 8 is called the base. And the base is in a power is the number that's being multiplied. So in this case, 8 is the number that's being multiplied multiple times, and the exponent tells you how many times we are multiplying that base. The entire expression is called a power. Okay, so I won't go through all the examples, but just as a little refresher, here's all the things you'll need to remember. And also keep in mind when you are applying the rules for powers, it is necessary for the bases to be the same. If they're not the same, then these rules do not apply and are not able to work. So, first one is the multiplication of powers. So if you remember, if you have two numbers, let's say x to the n, and you're multiplying it to x to the m, notice how the bases are both the same. So you can combine this and simplify it. It's going to be the same as x to the n plus m. So basically, when multiplying powers with the same base, all you have to do is add the exponents. Then we go through a number of examples here. Let's look at m. When we notice that they all have the same base, which they do, you can write it here, and then all of your exponents are just going to add. Remember, if there's not an exponent there, technically it's a 1, we just don't usually write it, so don't forget that. So 4 plus 1 plus 2 plus 3 would be 10. So we can write that as a single expression, m to the 10. I'm also going to do this one here. Commonly people forget it still works for numbers as well. So if you have something like this, the 2 is the same base all throughout, it's being multiplied. Don't forget this is a 2 to the 1. So you can add your exponents on the 2. 1 plus 4 plus 2 is 2 to the 7. And then the q is the same base all throughout. And then you can add your exponents there. 1 plus 3 plus negative 2 is going to give you an exponent of 2. And then technically you're done there, but if we know what 2 to the 7 is, which we do, it's 128. I can simplify this to be 128 q squared. Division of powers, same idea, but when you're dividing powers with the same base, you're going to subtract your exponents. So let's say we had something that looks like this. X to the n divided by x to the m. You could simplify this as a single expression. It's n take away m. Just be careful with your negatives here. Let's look at this one here. So if I have the same base, which is r, now I have a 22 minus a negative 3, which is the same as 22 plus 3. So be careful if you're minusing negatives, you're not getting mixed up there. And then this one here is a bit more complex. It's got a whole bunch of stuff going on with it. So what I would do is I'd simplify the top first. So you can see we're multiplying the top. So we're going to add our exponents. That will be the top. And on the bottom, I have this. And then now I can see it's a single expression divided by another single expression. So we can simplify it again. Now it's dividing, so I'm going to subtract my exponents. I'm going to end up with that as my final answer. And you can expand that 3 to the 9 if you want. It's actually a really big number, so I didn't bother. Power of a power. So when you have a power raised to another power, you can simplify this expression by multiplying the exponents. So in general, if I have something like this, an expression raised to a power and then raised to another power, that is going to equal that same base, and then those powers multiply together. So any of these would work. Let's look at this one here. So we have a power raised to a power, 9 times 9 is 81. And that's a single expression here. For these more complex ones, same thing, you have a power raised to a power raised to a power, so it's just going to be negative 2 times 7 times negative 3. And you can write it as a single expression like that. Okay, a couple more rules to go through. Power of a product and power of a quotient. So basically, if you have an exponent outside a set of brackets, you have to remember that the exponent applies to everything within the brackets. So an example here, something like this, the P is going to be applied to both the terms inside, and it's a power raised to a power. So you can see that it'll multiply both the exponents inside. So let's look at a couple of these. I'll do the trickier ones. Don't forget, it still applies to the number. If that number is inside this set of brackets, the 4 is also going to be an exponent for that. So this is going to become negative 2 to the 4th, m to the 4th, n to the 24th, p to the 8. I'm multiplying that 4 to all the exponents. Remember, if they're not there, it's like it's a little 1. We just don't write it. And then I can figure out negative 2 to the 4th is the same as 16. And now I've simplified that expression. Same thing with this one here. This exponent 2 applies to everything, including the numbers. Most common mistake. It'll apply to absolutely everything. So that's going to look like a 2 squared p to the 6 over 8 squared q to the 4. Don't forget that. Some of you are going to forget it. I know what 2 squared is. It's 4. 8 squared is 64. And then remember, from simplifying rational expressions, looking at 4 over 64, I can simplify that just like a regular fraction. And it simplifies to 1 over 16. So my final answer is going to be this when it's simplified. 0 exponent, not much to remember about that other than when anything is raised to the exponent of 0, it will always equal 1. But you have to be a little bit careful with that. So here, 12 exponent 0, that's just a 1. But let's look at the difference between this and this one. You have to be a little bit careful. Here, your negative is inside the brackets. Here, it is outside the brackets, and your answer will be different. If the negative is inside the brackets, it means it's under the influence of that 0 exponent as well. So that whole expression is going to equal 1. But here, that negative is outside the bracket, so that means only this part inside the brackets is equal to 1. So you're left with a negative 1 as your solution there. So be very careful about that. Okay, 2 more topics to cover for review. We're going to talk about negative exponents. And you have to remember, when the exponent is negative, the standard form is the reciprocal of the same power but with a positive exponent. So in general, if I have a negative exponent, I can write it like this. Okay? It's just the reciprocal of that base, and then you can turn that negative exponent positive. And these, I find people also make the most mistakes on the negatives. So let's have look at a few examples here. Okay, let's look at this one here. There's 2 different ways you can look at it. You can either flip your fraction now, make it a reciprocal now, and then change that exponent to be positive. That's fine. And when you figure out that, it's going to be 3 squared over 2 squared, which is 9 over 4. That works. Or what you could do is go straight and apply that negative 2 to both the top and bottom now, and now you can take the reciprocal of it to make them positive exponents. You can see either way that you like to do it, you're going to get the same answer, so it doesn't really matter. Be careful if there's a negative in front. I find that's what makes people confused. Negative exponents have no impact on that negative whatsoever. So basically what we're going to do is we're going to take the reciprocal of negative 1/2, which is just a negative 2. And then I'm going to change my exponent to a positive. So don't let the negatives in front mix you up. And then negative 2 exponent 3 is a negative 8. And same idea with this guy here. There's different ways you could approach it. I applied the negative 4 to both right away. So that means power raised to power, you multiply your exponents. So I'm going to get this. And then there's nothing else to simplify, and that one's done. Okay, the last little bit that I added in there is exponents that are fractions, rational exponents. We did touch on this before as well. It's another way of writing a root. So here's the power form. So you have a to the fraction of m over n, and this is how you can write it as a radical. So anytime you have a fractional exponent, it's actually telling you you're taking a root of something. And that's how you set it up there. So looking at a couple of these, I don't know, I'll just pick this one here. The bottom number tells you what type of root you're taking. The base stays the same for both, and then the top number tells you what power you're raising that to. And if you put that in your calculator, you'll see it's the 16. Okay, and if it's a square root like this one here, the bottom number is a square. Usually we don't write the 2 in here. The standard form when it's blank is that you assume it's a 2. And you get that. We can also go the opposite way. So if I give you it in radical form, now you can put it in exponential form. So remember, if it doesn't say what type of root you're taking, it's always a 2. So this is going to be 49. This 2 is always the bottom of your fraction, and the top is the exponent that this was raised to. It doesn't have anything written, so we know it's like a 1. Let's do this one here because it looks extra fun. First of all, what I do is change that root into its exponent. So again, this number here goes on the bottom, and whatever it was raised to goes on the top. And then to be perfectly simplified, we should get rid of that fraction altogether. I can move this out of that fraction by taking the reciprocal of it and giving it a negative exponent. It means the same thing. That's it for today, so make sure you do go through some of the practice with this so you're pretty familiar. It will apply on our next day's lesson. Have a great day.